Section 5.3, concurrent lines. There is a lot of vocab in this section, so definitely want to take good notes and make sure you learn the vocab that goes along with it. All right, first two theorems. The perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. Concurrent is a new word to us. This word right here. It means that the points all meet the lines all meet at the same point. All right, and that point happens to be equidistant from all the vertices of the triangle. The second theorem, the bisectors of the angles of a triangle are concurrent, so they all meet at a point that's equidistant from the sides. And we're going to see this in a minute. All right, there's your official definition of concurrency, a point where two or more segments meet. This is the first center of a triangle. There's going to be four of them that we're going to study. So this would be a good time to remember what's going on with this. So, official definition that you probably should know, it's the point of concurrency of the perpendicular bisectors of a triangle. So we draw the perpendicular bisectors, and then we can use the point where they all meet to draw a circle as using that point as our center that will pass through all the vertices of the triangle. It's called the circumscribed circle. Okay, so in Sketchpad, I have this. So perpendicular bisectors have to go through the midpoints of the triangle. So there's our perpendicular bisectors. All right, and the point where they all meet is called the circumcenter. And we can use the circumcenter to draw a circumscribed circle that touches all three vertices of the triangle. And as you move this, the circumcenter changes different places. Okay, so right now the triangle is a cube, so it's inside the triangle. But if I make B a right angle, the circumcenter goes to the midpoint of the hypotenuse. And then if I make B an obtuse angle, the circle gets really big, and the circumcenter is out here, outside of the triangle. Okay, so that's a little different. All right, so that's center number one. So on a graph, this is obviously a right triangle. And so if you remember what I just said, the circumcenter is in the midpoint of the hypotenuse. So the circumcenter is right here on this triangle, and that's 2, 3 at the point 2, 3. They're the only triangles that you can do on a graph. Everything else requires a compass. Alright, next center is called the incenter of a triangle. This is the point of concurrency of the angle bisectors of a triangle. And we can use that point to draw a circle inside the triangle that touches all the sides of the triangle. Okay, so in this triangle, there's the angle bisectors. So that's the incenter. And then this is the inscribed circle, and this one's not working the way it should. But as I move the triangle and I change the dimensions of the triangle, that circle stays inside the triangle, so the incenter stays inside the triangle, always. Okay? So that's two centers of the triangle. Alright, new vocab term, a median, kind of like the median in the road. The median goes from a vertex to the midpoint of the opposite side, so it's this blue segment right here. And we can draw one for each side. Okay? And this would be the third center of a triangle. It's the point of concurrency of the median. It's called the centroid. This is the center of gravity of a triangle. So if you take a triangle and you try to balance it on its centroid, it will always balance as long as the centroid is constructed correctly. Okay? So in Sketchpad, medians go to midpoints, so there's our midpoints, and we draw the medians. And then that point right there is the balance point. And regardless of how I move this triangle, that point has to be in what we call the center of the triangle. Okay? Alright. Now there's a little calculation that goes with the centroid. Okay? All three medians are drawn on this triangle, and then here's the centroid at C. So the distance of the median is split into thirds. So the top half is 2/3 the whole length. The bottom is 1/3 the whole length. Okay? And notice how the top is double of the bottom, or what I'm calling the top and bottom. Okay? 2/3, 1/3. So, like in this picture, they tell us D is the centroid and DE is 6. So DE is the 1/3 section. That means BD has to be double that because that's how they work. So then BE would be the entire segment, and that would be 18. Alright, altitudes. These are the perpendicular segments from a vertex to the line containing the opposite side. And I say line containing the opposite side because on an obtuse, the only way to draw a perpendicular to two of the sides is to kind of extend the line out, like they do in area problems, and draw the altitude, okay? And the altitudes are always perpendicular. So ST, median and altitude are neither. If we look at ST, it's perpendicular. It's not to a midpoint or anything crazy. So it has to be an altitude. And then UW goes from a vertex to the midpoint of the opposite side. So that's a median. Alright, now the lines that contain the altitudes are concurrent, and that point is called the orthocenter. That's our fourth center today. Alright, so in Sketchpad, altitudes are drawn perpendicular from the vertex to the opposite side. So all of these lines are perpendicular to the sides. And the point where they cross is called the orthocenter. So if you move this around, notice as I make B a right angle, the orthocenter is on the right angle. If I make B obtuse, the orthocenter goes outside the obtuse angle. Okay? If it's acute, then the orthocenter is inside the triangle. Okay? That's all it does. It doesn't draw any circles or anything crazy like that. Alright, a little bit of recap. A perpendicular bisector. This would be a segment that is perpendicular to another segment at its midpoint. An angle bisector is a segment or a line or a ray that cuts an angle in half. A median is a segment that goes from a vertex to a midpoint of the opposite side. An altitude is a perpendicular segment from a vertex to the line containing the opposite side. If you need to get these, pause it, go back, whatever you need to do. Alright, these you need to know what segments make them. So a circumcenter is made by perpendicular bisectors, and it's the one where you can draw the circle around the triangle. An incenter is made by angle bisectors, and you can draw the circle inside the triangle. The centroid is made by medians, and that's the balance point of the triangle. And then an orthocenter is formed by altitudes. Okay? All of this is important information that you need to know for later.